Okay, everybody, today's likely to be a shorter video. Today's lesson is all about absolute value equations. We've been dealing with equations in word problem formats and in normal equations, two-step equations, fraction equations, things like that. We've basically been getting a quick review, a quick recap on how those things work and how to solve them. So today, we've got one more thing we need to address with equations. And I believe this is the last thing that is going to be on your quiz Friday. The stuff I talk about tomorrow will not be on the quiz. I'll try to keep it to the Monday through Wednesday. That content is what gets quizzed. But the other stuff, you'll have until the next day or so to really figure it out and then be assessed on it later. At least for now, that's kind of the plan. So with that in mind, this shouldn't be too much trouble. Your quiz is just going to be a lot of solving equations and coming up with solutions in that way. But let's get into it. First of all, we need to talk about what absolute value means. Absolute value. Okay, what does that mean? Well, if I were to take a number, and let's say the number I took was 12. Okay, 12. 12 has a value, right? It has a numerical value. We give it context based on the numbers around it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And it means something to us. We can count that value out, right? That's what it has. It has that value. But there is this idea of a number having an absolute value, that is a value that is true based on a set standard. Absolutes are things that are final and defined based on a specific standard. So the number 12 has an absolute value based on a certain specific standardized value. And of course, that number is 0, okay? When I'm talking about absolute value, I'm saying that I am basing my calculations at 0, and I'm trying to find the distance from 0 to that number. And a distance, because it is a measurable value, is always a positive value. So in this case, if I were to take the absolute value of 12, that would be 12. If I were to take the absolute value of -7, that would still be 7, because I have to go 7 units to the left to get to -7 from 0. So I can count out those 7 units. And that's what absolute value does. That's what it does. It turns any number into a positive value by measuring that number's distance from 0. Okay? Now, that's the absolute value part of our lesson for today. But there's an extra twist, because we're talking not about absolute value numbers, we're talking about absolute value equations. So now we're going to take everything that we've been talking about the past few days, the past week, and we're going to start bringing this into the context of absolute value. We're going to add that extra wrinkle to our process. Okay? So, let me skip ahead a page and let me give you an equation. Our first equation is going to be the absolute value of x minus 7 equals 3. The absolute value of x minus 7 equals 3. Now, we're going to treat absolute values for today's lesson as though they function as a set of parentheses. That is, they wrap everything around them in a bubble of absolute value. And whatever this thing on the left is, I'm going to absolute value it, and I'm going to get a positive 3 answer. Now, in order to get rid of the absolute values, okay, in order to properly solve this, I need to get rid of these, because just like with parentheses, if I had parentheses x minus 7 equals 3, the parentheses technically stop me from moving the 7 over until I've gotten rid of them. Now, in this case, there's not really anything stopping me from just dropping the parentheses off, right? But with absolute value, it's a little bit different. Absolute value, there's a specific and precise way that we drop those lines, those bars, okay? And it's by thinking out loud or on paper or however you process this about the two values that could potentially create the number on the right if they were to be in the place of these of this x minus 7. If instead of x minus 7, okay, I had just a number inside of these bars, okay, what number would that have to be? Well, it would have to be either 3 or -3. Those are the only two things that could fit inside these bars to be equal to +3 after I took the absolute value. So that means that x minus 7 has got to be equal to either 3 or it's got to be equal to -3. So the way we drop the bars is we drop them and we set whatever positive value this was to equal to x minus 7, and then we change the sign and set it also equal to x minus 7. Okay, whatever was in here ends up being equal to both the positive and negative versions of this number. And then we solve. We know how to do this. Add 7, just do that opposite process. And we'll do the exact same thing over here as well. Add 7. We get x equals 4 over here, and x equals 10 over here. That means that for the very first time in this class, and definitely not the last, x is actually equal to two things. X is equal to 4 and 10. Okay? And you're allowed to write them separately like this or together like this. Either's going to be fine. I'm not going to be super picky on that on your assignments. Okay. Let's take a quick break for TIA, and then we'll come back and we'll look at a few more examples as well as a few edge cases. Okay, welcome back. Let's look at 2 absolute value 3 parentheses x minus 7 close parentheses plus 3 close times absolute value equals 36. Okay. What do we do with this? Well, we treat these like parentheses, right? The absolute value bars, we have to treat them as though they're parentheses. So the first step is to get rid of the stuff on the outside of the parentheses. We want to get this piece away from these. I guess normally you would try to distribute inside, so maybe my advice isn't perfect. But it is worthwhile to note that 2 is being multiplied by all the stuff inside the absolute values. So an opposite process to that might be, instead of doing distributive property, we might choose to divide by 2. Okay? And in this case, that's preferred. It's not easy or really very wise to try to move things into absolute values, but we can move things around them on the outside. We're allowed to do that. And this is going to become 18, and this is going to move down with its absolute value bars, right? Let me make that a little clearer. Good. Okay. Now, like we saw earlier, the way to solve this is to change this value into its positive and negative forms. 3x minus 7 plus 3 equals 18, and 3x minus 7 plus 3 equals negative 18. And we're going to work our way through this and solve. Okay? First things first, we should probably subtract 3, subtract 3, subtract 3, subtract 3. We get 3x minus 7 equals 15. 3x minus 7 equals negative 21, right? Okay. And then again, we have an option here. We can choose to distribute, which I'll do on the right. So 3x minus 21 equals negative 21. And I can add the 21 on both sides. That cancels. We get 3x equals 0, which means that x, one of the solutions for x is 0. And then here on the left, okay, instead of doing that whole distributive property nonsense, I'm actually going to choose to divide. Divide by 3. Divide by 3. I get x minus 7 equals 5. And then I add 7 on both sides. And x ends up being equal to 12 on the left. Alright? Both of those are viable strategies to getting to your solution here. And both of these are the solutions. X is 0 and 12 for this problem. Okay? We can choose to use distributive property to solve it out, or we can choose to divide by the coefficient on the outside and work it out that way. Both are great ways to get your solutions here. One quick edge case. One thing we have to make sure that we watch out for. Most times you're going to get 2 solutions. Most times. But there will be a few times where you'll get no solution. And I'm here to show you what that looks like. If you have absolute value x minus 35, let's say, okay, and that's equal to negative 15, okay? Remember that our first step is to drop off the absolute value bars by looking at this number and saying, okay, what are the positive and negative values that I can plug in here in this box to make this answer happen? Okay? And the issue with that is that in this case, there is no absolute value number. If I took the absolute value of 15, there is no number that can possibly give me a negative 15, because there is no negative measurement between two numbers from 0 to that number. It's not possible, it's not real, it doesn't happen. So if you have a negative value on the right side of the equal sign, okay, that means there's no solution. Okay, I guess I should clarify. If there's a negative on the side that doesn't have the absolute values, okay, then that means there's no solution. Do watch out, because sometimes you'll get a problem that looks more like this. Negative absolute value x plus 2 equals 5. Okay. On the surface, this looks like we'll have a correct solution. But again, we first have to deal with the stuff that's on the outside of the absolute value bars. I would have to move this negative over, so it would become absolute value x plus 2 equals negative 5, and we're right back to the same issue we had on the last problem. Okay, the side that is not the absolute value thing now has a negative. See, now has that negative, and that means that once again there is no solution that satisfies this. There's no number I can plug in for x that, after calculating it, gives me a negative 5 after taking the absolute value of it. Just not possible. Okay, so watch out for that. That's the one edge case possibility that is in this problem type. So good luck on that. Good luck with your homework. And of course, as always, shoot me an email if you get stuck with anything.